another question in the series which actually says the projection of vector A on vector B. So we've been given two vectors, vector A and vector B, and that the projection of vector A on B is 0. Now, what is projection of vector A on B? Is equal to vector A dot vector B by magnitude of B, which is equal to 0. Now, vector B has a definite magnitude. Therefore, this denominator cannot be equal to 0. Therefore, vector A dot vector B has to be equal to 0. Now, if vector A dot vector B is equal to 0, the given two vectors 2i plus 4j minus 2k, my bad, it should be dot I plus 2j minus alpha k is equal to 0. Now, how do we take the dot product? So we know that I dot I is equal to j dot j is equal to k dot k is equal to 1, right? So 2i dot 1i is equal to 2 into 1 times I dot I, which is 2 times 1, which is equal to 2, right? Similarly, 4 times 2 and minus 2 times minus alpha, which further gives us 2 times 1 is 2, 4 times 2 is 8, minus 2 minus alpha is, wait, my bad. Did I make a mistake here? Minus 2j, I plus 2j minus alpha k. Yeah, so minus 2 times minus alpha. Oh, I think there might be a difference. Let me just check what is there in the actual question which came up in JEE Mains. Okay, I see. So the actual question is actually 2i plus j plus alpha k. Well, it doesn't matter. It's just arithmetic that gets very, that shouldn't be a problem at all. Even with this case, what we get is plus 2 alpha, and what we get is alpha is equal to minus 5. Whereas in the actual question, it is instead of minus alpha k, it is plus alpha k. So this will be minus 2 alpha, and minus 2 alpha when transpose will be plus 2 alpha, and therefore alpha will be equal to plus 5, right? 8 plus 2 is 10. Yeah, 10 by 2 would be 5. So yes, we get the value of alpha will be equal to 5. Now, this is the concept we need to understand in detail. What is the physical meaning of projection of vectors? What does it actually imply physically when we say a vector is projected over another? So what we'll do is we will divide this into two divisions. Okay, one, we'll see how do we derive at the formula projection of vector A on B is vector A dot B by vector B, and we'll also try to understand the same with respect to an example of the projection of wind. What's going wrong here? Okay, projection of wind on the wind vector on the displacement vector of an aircraft. Okay, and then we will also see some more examples regarding this as we go through the next set of questions. So yes, that was it for the solution. Now moving on to the derivation of projection of vector A on B.